In this problem, skier of mass 50 kg is being pulled uphill by a rope tow, and then the slope makes an angle of 30 degrees with the horizontal, and then the ski is moving at a constant speed, which means acceleration is zero. The tension of the rope is 280 newtons. We have to find the kinetic friction and the coefficient of kinetic friction. So let's assume that we're going to explain this to a friend. So these are the steps. You have to choose positive x direction and y direction. Draw a free body diagram and then determine the x and y components of each force acting on the skier. And then use Newton's second law in x direction to find the kinetic friction, and use the Newton's second law in y direction to find the normal force, and then calculate the coefficient of kinetic friction. Now let's start by visualizing the problem. So let's draw a free body diagram. Before that, let's define the positive x direction and positive y direction. As you can see, I have already drawn the free body diagram. So let me explain you the x-axis. X-axis is along the inclined plane, and then y-axis is perpendicular to the inclined plane. I have taken up the inclined plane as positive x-axis, and then y-axis is perpendicular to the inclined plane. So it's very important to draw a diagram and then identify the knowns and unknowns when you solve a problem like this. So now let's see the forces acting on the skier. It's important to identify all the forces acting on the skier. First, his weight directly downwards, and then tension force up because he's moving up the inclined plane. Normal force perpendicular to the surface. Surface is pushing the skier up, and then kinetic friction. Friction always opposes motion, so it is down the inclined plane. Weight is equal to mg, mass of the skier is 50 kilograms, tension of the rope is 280 newtons. Now the angle of the inclined plane is 30 degrees, and as you can see, this is a right triangle. If that is 30, that should be 60, which means the angle between the weight and the y-axis is 30 degrees. And then acceleration in x direction is equal to 0 because skier is moving at a constant speed. Remember, average acceleration is defined as change in velocity over change in time. If there is a constant value for the speed, then there is no change in velocity, so that means acceleration is 0. Now, if you look at the weight, now you can resolve this weight back to two components. One along the y-axis, mg, cosine of 30 degrees, is the y component of weight, and then x component of the weight is mg sine 30. You can say this is a right triangle. Use your knowledge on trigonometry to resolve the x and y components. And applicable concepts, this is section 5.1. Coordinate system is specified, and we are trying to solve for the kinetic friction, and you measure friction in newtons because it's a force, and we expect negative sign because based on the coordinate system. And then we are going to solve for mu k, the coefficient of kinetic friction, and there's no unit rate, and it is normally it's not negative, so we expect a positive value. And let's start by making a chart to identify the x and y component of each force acting on the skier. So let's start by the normal force, and there's no x component for the normal force. Y component is Fn. It's positive because it's up based on the inclined plane, and then tension has an x component, and it's again positive based on the coordinate system, and then kinetic friction is negative based on the coordinate system. Friction opposes the motion, and weight has a x component and a y component. By looking at the vector triangle, you can see the x component is mg sine 30 and y component is mg cosine 30. Both of them are negative based on the coordinate system. Now let's look at the equations. We're going to use the equation for the kinetic friction. Kinetic friction is equal to coefficient of kinetic friction times the normal force. And the net force acting on the object is equal to mass times acceleration. This is Newton's second law. But we are going to use the component form of the Newton's second law. So net force in x direction is equal to mass times acceleration in x direction. And then net force in y direction is equal to mass times acceleration in y direction. So now let's execute our plan. Once you have the chart, guys, it's really easy to execute the plan. So let's start with net force in x direction is equal to mass times acceleration in x direction. There's no acceleration in x direction because the object is moving at a constant speed. And we have to just add all the components of forces acting in x direction. Tension minus Fk minus mg sine 30 degrees is equal to 0. And since we are solving for kinetic friction, I'm going to get an expression for the kinetic friction. It is equal to tension minus mg sine 30 degrees. And then I'm going to use Newton's second law in y direction. And I'm going to look at the chart and then identify all the components of forces acting along the y direction. Abnormal force minus mg cosine theta is equal to 0 because there's no acceleration in y direction. And if you solve for the normal force, you get normal force is equal to mg cosine of 30 degrees. And I'm going to solve for the normal force here. Mass is 50 kilograms and then g is 9.8 meters per second squared times cosine of 30 degrees. If you solve for the normal force, you will end up of getting 424.4 newtons. And I'm going to now go back to the next step. So my next step is to use kinetic friction is equal to coefficient of kinetic friction times the normal force. I'm going to use that equation, but before that, let me go back and solve for the kinetic friction force because I already know the tension. It's given in the question and I already know the mass of the sphere and I can easily solve for the kinetic friction because anyways I have to solve for it. So 280 newtons minus mass 50 kilograms times 9.8 meters per second squared times sine 30 degrees. If you solve for the kinetic friction, you will get 335 newtons in negative x direction. Okay. And then I'm going to use Fk, kinetic friction is equal to coefficient of kinetic friction times the normal force. And I'm going to use this and solve for mu k. I'm going to separate it and mu k is equal to kinetic friction divided by the normal force. I have solved for the kinetic friction. I got 35 newtons. And for the normal force, I have 424.4 newtons. Divide, you get I'm solving for it now. So let me see what I get. I get 0.0825 for the coefficient of kinetic friction. As we expected, there's no sign for the coefficient of kinetic friction. Newtons to newtons will cancel out. And you get the answer with no units. And it's not negative because it doesn't have a direction. It's just a coefficient. So is the solution complete? Yes. And is the sign of the answer correct? Yes. We got the expected signs for the coefficient of kinetic friction and then kinetic friction. And then, does the answer have correct units? Yes. We got newtons for the kinetic friction, and then there's no unit for mu k. And the magnitude of the answer is they're reasonable. So look at the process, guys. That's the most important thing when you approach a question like this. You should know the process. We started by visualizing the problem. We have the free body diagram, and then we solve for the x and y component of each force, and we use the component form of Newton's second law to solve for the unknowns.